What is up, Metheads? Today here in Oahu, Hawaii, we actually experienced a little bit of rain due to the tail end of a cold front connected to a mid-latitude cyclone that is well off to the northeast of us. And in this video, we're just going to look at the development of this weather system and look at what might happen in the future with it. And in order to do this, we're going to look at a week in the past and compare this IDV meteorological chart with GOES 18 West satellite imagery. And then to look at present conditions, we're going to refer to the University of Hawaii Manoa's weather server. And then by using model data, we can take a glimpse into the future. So first, I want to address that if you refer to my previous video on IDV installation, when you install the MAPES plugin, you will get access to this AMS LMT lab manual, and I am currently looking at the Chapter 1.3 Real-Time GFS Global. And I have loaded what you're looking at currently is January 20th, 18 UTC, which is 8 a.m. in Hawaii. And this is about a little over a week ago from today. And we're going to compare what we see in these charts with the satellite imagery here, the RAMMB Slider run by Colorado State. And this is a wonderful resource. I'll link it in the caption below that you can access to look at satellite imagery. And it's not just GOES 18, you can choose other ones, but we are going to take a look at 18 because it is focused over the region of interest that we want to look at. The GOES 18 has individual ABI bands, which is the Advanced Baseline Imager, and it measures energy reflected from and emitted by the Earth and its atmosphere at different wavelengths. And as you can see, there are 16 spectral bands in the ABI. And these multispectral imageries combines data from multiple ABI bands to create these products, and the one that I'm currently looking at is the GeoColor. And what's wonderful is that you can control the time steps at what you're looking at, so I have it looking at 6-hour increments with every time step. And you can control the dates that you're looking at. So I had preset the 20th through the 27th. So let's go back to the IDV. In this IDV chart, we are looking at pressure reduced to mean sea level in red contours and 500 millibar geopotential heights in black contours. This shows us the jet stream, as we see here by these tightly packed contours running from west to east. The temperature shading is showing temperature at 1,000 millibars. We see that the coupled low pressure systems have conjoined, forming a larger low pressure system, and there is a new trough at the surface and in the jet, forming to the northwest of Hawaii. We can see these in satellite imagery. Again, this is the 20th of January, with the coupled low pressure systems originally, that tighter one well off to the north under the Alaskan Peninsula, and this looser one below it, in between, or below it, to the south of it, and as well as the subtropical high to the west of Hawaii. Going forward a day, we see the conjoining of the low pressure systems into one larger one, and that trough that I mentioned that's off to the northeast is starting to form this storm system we see right here. Let's look back at the charts going forward another day. the trough has moved over to the north of Hawaii, and the subtropical high has pretty much stayed where it is. Moving forward another 24 hours, that trough we were looking at before, or the low pressure system, now is moved over closer to the west coast of the United States, and that trough we mentioned earlier that developed behind is now developed into a stronger storm. Assuming geostrophic flow, we see westerly winds. This clockwise turning of the winds with height indicates warm air advection, or otherwise what we call veering winds. What that means is that warm air from the south is getting advected up to the north, and when we look at the upwind side of the trough, again, we are seeing westerly winds at the mid-troposphere, but at the surface, we are seeing northwesterly winds, so winds coming from the northwest. This counterclockwise turning of the winds with height is what we call backing winds, and that indicates cold air advection. But what we're keeping our eye on is this developing storm system right over here. And looking forward in time, we see that going on another day in advance, we see how much this storm system has strengthened. It is now pretty much directly to the north of Hawaii, and we see really strong warm air advection on the downwind side of the cyclone, and again, we are still seeing some pretty strong cold air advection on the upwind side of the cyclone. Moving forward to the end of the time steps that we have, we see that the cyclone stays where it is for almost a whole 24 hours. And during this time, it is pulling up moisture and warmth from the south and bringing it up to the north. And all of this is pretty much traveling directly over Hawaii. And moving to the end of the time step, we see that it eventually, as cyclones do, resolve itself and return to equilibrium after it's done what it needs to do in helping the atmosphere reach its equilibrium. Moving forward, this is 8 a.m. on the 24th, and we see how much that storm system is strengthening, as we saw. And as we talked about, it does its thing, dissipates, and it has been resolved. This is now looking at 9 a.m. this morning. We see how this cold front is progressing to the west, flowing over Oahu. And as you can see here, these are the gravity waves produced from the Ko'olau Mountains on the windward coast of Oahu. What I want to show now is the surface pressure charts attached with cold front and warm front lines. This website is a National Weather Service provided forecast chart. To access this, I go to weather.gov/HFO/analysis, and I click on the North Pacific Surface Analysis. We'll go ahead and click on the loop, and we see current conditions. Right now, we see that there is a low pressure system, a pretty strong storm, up to the north of Hawaii, and currently crossing over us is the tail end of the previous low pressure system that is now extended over to the Pacific Northwest. We can see these here in this imagery. We are looking at the 30th at 1 UTC, and as we said before, there is the previous storm system dissipating itself over at the Pacific Northwest, and this stronger storm system off to the north of Hawaii. And this storm system is what's bringing us the rain that we saw today. Current conditions at the Honolulu airports is 74 degrees, and our relative humidity is pretty high at 91%, which makes a lot of sense considering how much moisture is being infected over us thanks to this storm up here. Looking at the radar composite, we can see that this rain band is passing over the now eastern islands. Looking at the infrared, we see channel 13, which is the clean infrared channel, and it operates at 10.3 microns. And here we can see what's really nice is that it allows us to see clouds pretty much at night, unlike the visible channel. And again, we see that really strong system up to the north of us, and as it drags along, moisture that's being sucked up pretty much from the equator and infected over Hawaii. And lastly, we see water vapor, which is showing upper level moisture, essentially. What we're interested now that we see, now that we've talked about what's currently happening, we'll take a look at the future, colored by the color scale here. We see that the white areas is very low precipitation, almost none. And as we get up into the blues and greens and reds, that indicates heavier precipitation. We see that storm system that is off to the north of us. Oh, I should mention the time that we're looking at. So this is model data developed by the Mauna Kea Weather Center in cooperation with UH Manoa. So first we're looking at essentially right now, and we get to look at a couple days into the future, specifically 7 days into the future. And we see that storm system is going to continue off to the west, dissipate, and this secondary system is going to develop, possibly bring some rain to Hawaii as indicated by this green coloring that occurs at around, let's wait for it, at around like the first couple days of February. We'll see some more precipitation is possible thanks to this developing system. One more resource that I want to share is this wonderful website, windy.com, and you can also access model data here. Right now we are looking at pretty much the current time in wind speed, colored, but we can change this to look at rain. And as we progress into the future, we can see how this system will eventually move off, and this secondary system that we were thinking would possibly bring us some rain is beginning to develop. Between Thursday and Friday this week, we might see an increase in rain thanks to this small low pressure system that moves off. And as we talked about before, after that little system moves off into the weekend, we will see a return to our trade wind regime thanks to this high pressure system off to the north. So, with that being said, this concludes my past to present to future analysis of the weather conditions we are experiencing here in Hawaii. Thank you so much for watching, and I'll see you guys in my next video.